Okay, now I would like to take a look at how we calculate for acceleration. These problems are very similar to our speed problems and our velocity problems. There is one additional step, and that is that first we have to calculate our change in velocity, and then we can plug that into our triangle. Okay, and once we've done that, then we use the same algebra concepts that we've been using this whole time. So once I have my change in velocity, if that's what I'm solving for, or if that's what I'm looking for, I get that first. Then if I want my acceleration, I cover up acceleration, and I'm going to take my velocity or change in velocity divided by time. If I'm needing this, but I have my acceleration and time, I'm going to cover that up. Acceleration times time is going to give me my change in velocity. And if I'm looking for time, I cover that up and I take change in velocity divided by acceleration. Okay, so the notes here represent some of the changes that we see in our triangle. And the little mini triangle right here, that means change. Okay, if it's triangle V, that means change in velocity. And what our change in velocity is going to look like, it is going to be our final velocity, so how fast the vehicle or ball or whatever it is that's moving was moving at the end of our time period, and our initial velocity is how fast it was moving at the beginning of our time period. So for example, if you hear someone say something like a car accelerates from 0 to 30 kilometers per hour in a specific amount of time, however many, minutes, seconds, whatever, you're looking at the difference from 0 to 30 kilometers. Okay, to find the difference, we subtract. So you take your end or your final velocity, subtract your beginning velocity. So it's going to be 30 kilometers per hour minus 0. And so your change in velocity is just 30. Okay, so that amount is what you would plug in here. Okay, so let's try a problem from our homework. As an example, and this comes from the acceleration calculations worksheet, number 3, okay? It says a cyclist in the Tour de France accelerates down a hill from 22 meters per second to a speed of 37 meters per second. This acceleration takes him 2 seconds. Calculate the acceleration. Okay, so I'm looking for my A. That's what I do not have. I'm given my time, which is 2 seconds. And I'm given 2 different speeds or velocities. I'm given 22 meters per second and I'm given 37. Okay, so what I need to find is my change in velocity. And I am given 22 meters per second was my start, my initial. And 37 meters per second was my final. That's my initial velocity and final velocity. Those are little baby V's. There we go. Okay. And, normally you would think subtracting things in order, 22 minus 37, that would give us the difference, but we would end up with a negative number. So since we're just looking for the difference, you take whatever the larger number is and subtract the smaller number. So 37 minus 22 is 15, okay? So it's 37 minus 22. We take our final minus our initial, and that in this case gives us 15. So our change in velocity is 15 meters per second. We keep the same units that we had. Okay, so now I have everything that I need to plug into the triangle to solve for acceleration. So my acceleration is what I'm looking for. And according to the triangle, I'm going to take my change in velocity divided by time. Okay, that's the formula that I use, and now I just plug in my information. My change in V is 15 meters per second. My time is 2 seconds. Okay, I'm going to divide that, 15 divided by 2, and I should end up with 7.5. And then with my units of measurement, I end up with meters per second. And it looks like that. But just like with math and science, there are certain rules and conventions that we go by, to decide like what things look the best way. And the general consensus is that looks kind of silly. And to say meters per second is kind of silly. So instead of doing it this way, we would write meters per second squared, since it's really seconds times seconds. So my final answer I would write like this. Okay, meters per second squared is my acceleration for, let's see, that was number 3 on the one worksheet that we were doing. Okay, so this is kind of the standard example of how to calculate for velocity. There are a couple of questions on the homework sheet that go beyond just looking for standard acceleration. And one of those would be about a Ferrari. Okay, so I'd like to take a second and look at the Ferrari question with you as well. Okay, so this is number 8, I believe, on our worksheet. I'm going to just slide this up a tiny bit, make sure that you can get all of it here. And so it says, if a Ferrari with an initial velocity of 10 meters per second accelerates at a rate of 50 meters per second squared for 3 seconds, what is its final velocity? And so here, instead of being given everything I need to find acceleration, I'm given acceleration, I'm given time, and I'm given one of the pieces of information for change in velocity, but not both of them. Okay, so I'm going to start this problem the same way I start all the rest of them, by figuring out what it is that I need to find and what I have. So for number 8, I'm being asked for the final velocity of the Ferrari. Okay, so I'm going to call that final V. That's what I don't know. That's what I'm looking for. Okay, I'm given the initial velocity, and that is 10 meters per second. I'm given my acceleration, which is 50 meters per second squared, and I'm given my time, which was 3 seconds. Okay, that's a lot of information. And if I set my formula up the way that, I have it aligned here on the triangle, then it looks like this. I normally would be solving for acceleration, okay? I can do this many different ways, but this is how we talked about doing it during class, so that's what I'll show you here. I'm going to set up acceleration equals final velocity minus initial velocity, and that's divided by time. Okay, this is the same thing as saying initial velocity, or change in velocity, sorry, at the top with the little triangle. Okay, I've just separated out that triangle in V. Okay, I can solve it this way, and that's what we did in class, so I'll go ahead and show you that here. Now I'm going to plug in what I have. Okay, my A is 50, and I'm going to leave out my units of measurement while I do the math, because they just kind of get in the way and make it look really busy. So just so long as you remember to put them on your answer, it's fine to do it this way. So I've got 50 meters per second squared for my A. My final velocity is what I'm looking for. In algebra, we would call that x, most likely. My initial velocity is 10. I almost wrote meters per second. And my time is 3. Okay? So my first step is I need to think about the process I go through to get the FV by itself. And I first want to get rid of this 3 at the bottom. And I'm dividing by 3, so I'm going to do the opposite and multiply by 3. And then these will cancel out. But whatever I do to one side of my equal sign, I have to do to the other. So these guys cancel. And I'm going to multiply that side by 3 as well. 3 times 50 gives me 150. And now I have 150 equals FV minus 10. Okay, I'm almost there. Now I need to get rid of this 10. Well, I'm subtracting 10 on this side. The opposite of subtraction is addition. So I'm going to add 10 to both sides. When I add 10 here, these 10s cancel. They go away. And when I add 10 here, I get 160. Now I have 160 equals final velocity. That was my final answer. Okay. I just need to have the units of measurement with my answer. So my final answer is 160 meters per second. Okay, that is my final answer. So, and when you get to the chart at the bottom of our second page of our homework sheets, there are a couple more like this. Okay, feel free to message me again if you get stuck on anything. Alrighty.